There are three basic types of stress that exist in Earth's crust: compression, tension, and shear. So in this clip we're going to go over the three types of stress, show what each of them are, show the types of deformation that can result in the crust as a result of the different types of stress, and then talk about where in the crust the different types of stress are likely to occur. So the first type of stress we're going to talk about is compression. And in this slide we have a block of rock up here at the top. It's not deformed at all, but we're going to put that rock under compression. So the blue arrows, they are there to indicate forces that are acting on the block of rock, and in this case the forces are acting directly toward each other, and so they're going to squeeze the rock. So that's what we mean by compression, when we have this squeezing force, and that can result in the rocks down in the crust becoming folded. See how these the rocks in this case have become bent or folded, and that's a common result from subjecting regions of the crust to compression over long periods of time. Another thing that can happen is the rocks can break and fractures can form, or, like we're looking at here, faults can form. Faults are simply fractures along which blocks of rock have moved relative to each other. So in this case we have this block of rock being pushed up and starting to try to go over the other block of rock that's underneath the fault here, and that'll result from subjecting the rocks in the crust to compression. So here's a picture of some folds in rock. These are sedimentary rock layers. You can see the layering, but the rock layers aren't horizontal, they've been folded. Here's a trough-like fold, we call that a syncline, and over here on the left we have an arch-like fold, and we call that an anticline. So these synclines and anticlines are formed down in the crust in solid rock because the rocks have been subjected to this squeezing stress. Squeeze the rocks from the side, you can deform the rock layers into these folds, anticlines and synclines. So our next type of stress is tension, and you can tell from the blue arrows that tension refers to a pull-apart kind of stress. It's sometimes called extension or extensional stress. And we can see down here the result of subjecting rocks to tension over long periods of time. What will happen is fractures will form in the rock, and then gravity will just pull blocks of rock downward along those fractures, or then we would call them faults. And so it results in a different type of faulting compared to what we saw forming due to compression. So later on in the learning module we'll go over the different types of faults and how they form as a result of different types of stress. Okay, now we're going to look at the third type of stress. It's called shear stress, and shear stress occurs when you have one force that's pushing in one direction on one part of a region, and then there's a different stress that's pushing in a different direction on another part of the region, and that will result in deformation and a certain type of faulting results. So in this slide we're going to see the type of fault that typically results from subjecting rocks in the crust to shear stress over a long period of time. It's a type of fault called a strike-slip fault. So the nature of the stress here is we're pushing on this right-hand side of the region into the slide, as the red arrow indicates, and there's another force that's pushing on the left-hand side of the region in a different direction, kind of out of the slide, if you will. And that results in the rocks on either side of this fault running through here shifting horizontally because they're being pushed in different directions. That's the nature of what we call a strike-slip fault. So let's review real quick and talk about where we'll see the different types of stress in the crust. Compression is that squeezing type of stress, and you might recall from our plate tectonics discussion that at convergent boundaries plates are colliding. So along convergent plate boundaries we'd expect the rocks in the crust to be under compression for a long period of time. And then the pull apart stress or tension, that's characteristic of divergent plate boundaries, or at least we'd expect that at divergent plate boundaries the rocks would be under this pull apart force because the plates on either side of the boundary are trying to move away from each other. And the third type of stress, the shear stress, that would be expected at transform boundaries where plates are trying to slide past each other. We'd expect the rocks along transform boundaries to feel that shear stress. Along divergent plate boundaries, the rocks would feel that pull apart stress or tension, and along convergent boundaries, the rocks would be under compression due to the plate collision for long periods of time. And the rocks in this crust will undergo deformation as a result.